Welcome to the SNN.Network Canada virtual event. I'd like to introduce our next presenter, Ofer Vicus, CEO of Aduro Clean Technologies. Ofer, the floor is yours.
Thank you very much. Hello, everyone, and thank you for having us. Thank you for taking the time to listen to our story. My name is Ofer, and I'm the CEO of Aduro Energy, the founder as well, Aduro Clean Technologies today. I'm joined today by our VP of Business Development. His name is Abe, and he's on the call, and perhaps will join in every now and then through the presentation, but also will help in the process of the questions and answers. We reserved about 25 minutes for this in total, and we hope that you'll gain significant information. My personal hope is that if anything to be taken from this presentation is that I know most of you are investors, so we want to make sure that you understand that we're unique. The business opportunity that we are representing is quite large, and given the right time with the right partners, there's significant activity that goes on in the company, and we will execute to translate it. We've been, in the last 10 years, under the radar. We've operated and did some research. It's a significant research that proposed a new technology or a new, after chemical conversion approach. And the first time that we received maybe a public acknowledgement by the article that we see on the right from the Forbes. The owner of this article has researched a range of the processes in the space of waste plastics. And perhaps it's the first time that we recognize us being unique in the space. And what does it mean? Basically, it speaks to the opportunity that we have on hand in terms of market size and the business deals that we can do. With that, I'll start the presentation. As Aduro is a public company, and of course, I have to present the disclaimer. We can't suggest anything from you. You have to make your own opinion about what we're doing, and we'll have to refer you, of course, to our SEDAR filing to get any further information. In today's presentation, I'll really go in a brief on the technology and the company. Most of you are business numbers guys, so I would anticipate that you want to hear a little bit of where we are, how we are unique, and what we're going to do in the next few years. So we plan some updates on information that we gained from our recent laboratory activities, and then as we are moving outside of the lab towards commercialization, we prepare some updates that we hope to get your attention around it. I know again that you guys will be interested in the 2025 activity that we will do, but overall, a bit of an history. We started in 2011. We've been working on this chemical conversion process for 10 years. We created a significant amount of patents in this short time frame, in this short time frame in the chemical sector. And in between, we've been working on the renewables, renewable oil as well. And so once we've been ready, we solidified ourselves through several other patents that are now transformed and maybe close the fence from the plastic application. Overall, we have 3 granted and 3 pending patents, and this is just the beginning. When we talk about the leadership company, I really wanted to speak also about the team behind us. So Aduro employ about 5 masters and PhDs in the background, and there is several very experienced consultant, significant research guys and C-level guys on the engineering that understand the market and the opportunities that we have. They're supporting us in the background, including our bankers that are joining this effort, and they are the engine, that makes this whole thing work. On the top from the leadership team, I'd like to go over it really, really quickly. If anything, I'd like to introduce our CTO. His name is Mark, and he's my partner and colleague for the last, founder of the company. And Mark's ability to envision and understand chemistry and, through mathematics, giving a lot of power to imagine things that we've been doing over the last 10 years. And as we started with the bitumen, just to give you an idea to, some of the patterns that we put right there at the first, the original intellectual property is as dated as 1930. And yet when we put our first patent through that type of imagination, we sail through with no rejection from the examiner. And so whatever Marx is envisioning, and there is reason there we can later elaborate, Neil on the other side, which was growing within the company, has been executing in the lab. Everyone else on the team is more of a supportive, of course, facilitators and our CFO that help us to do the RTO or business development, and myself as a CEO. This is everything that we will talk today about the technology. What is the hydrochemolytic technology and why we are so different, and what does it mean? It's a water-based chemical conversion. We're operating with a catalytic process and with a chemical agent. It operates in a low temperature, and it's very, highly configurable. So what does it mean for us? Well, most of the organization, it's easy to give examples on the plastic space. Most of the organizations are working, and some of the technologies are dated as early as 1940 and below. At the end of the day, they are coming with limitations. And so in terms of the market, you surely have seen a lot of activities in the plastic realm, for example, on the plastic realm where there is a lot of activity around it, but yet 90% of that market is up and open for us. In our activity, we actually don't compete with the rest of the organization. Because of the benefit that technology has, we are looking at the 80% that are open. So we can be more efficient if we will compete with the rest of the market. This is how we see the market. We have more opportunities to capture market from what is out there and free, and that's the benefit that technology has been enabling us, allowing us to do. We have three applications: bitumen and renewable, as well as plastic. They all share the same denominator. In the bitumen action, we are able to upgrade heavy crude and increase the value of it in a low-scale mode. In the renewable action, we are able to do renewable oils as well as chemicals, and again in a low-scale fashion. And we kind of left the renewable sector a little bit behind and focused on plastics and bitumen right now. But we are gearing ourselves towards working with the renewable going forward. And in the plastic application, we're capable of processing plastic that is generally hard to process in general. And that gives us advantage because in concept, what it means that you can do smaller system at less capital cost, less investment, less setup, and higher product, and that's what we are actually bringing to the market. And so that, again, catered to the size of the market, while most of the organizations that we see, and I'll show you the graphs, are catered towards, they have some specific needs and limitations. We are breaking apart from those and enabling to process plastic that is hard to operate on in a very low-cost activity. The next slide suggests a little bit of what I just told you about. For most of the time, you would find that organization has a specific setup and chemical limitation that cater to a different size, different scale up. And we think that if you've seen a lot of this waste coming outside and, all around us, that then, some of you have to ask, well, why this is not being dealt and done? The reason is because it comes with certain limitations. And so today's society is really looking for ways to solve those problems quicker and faster. And this is the area where we think Aduro has a big advantage on the rest of the market. And this is where we think we are leading the pack in a way. And so the ability to be configure and to provide solutions, immediate solution at a lower cost, closer to the place where there is contamination, is quite significant, and sometimes even in areas where there's no regulation. And so with that, we offer the vision of doing the maximum to recover higher value of chemicals and feedstock, sometimes to circular production, sometimes into fuel, while doing the minimum, lower capital costs, lower energy, lower footprint. That's kind of where we think our benefit is. And again, if Aduro has this ability to process plastic that is harder to process, that needs a little bit more capital cost and organization, then we have a lot to business opportunities to capture. And so, what is it we're talking when we're talking about the plastics? Most of the time, what you see in this type is material that is really hard to process and to recover material out of it. And so current technologies, and I'll show it to you in the next slide, has limitations. And so it's not that they cannot process it, but if we'll take a pyrolytic approach for plastic, so those limitations dictate that they will have maybe a hydrogen fan on the side, and they'll have to be selective in the selection of material that they will have to process in. So of course, immediately you're thinking, okay, so the value of feedstock that they need to work in has to be higher because somebody has to do some more work on the sorting activities. And so the way we are approaching it is that we can process this material in a lower cost. And I'm giving the example of plastic packaging, which is sometimes a build of a different type of families of plastics altogether, which ends up for most of the time in the landfill or incineration. But what I'm trying for you to understand is that the opportunities that we have, because we can cater to this mixture, a vast amount of mixture of plastic, which is really different types of chemicals, we have those opportunities to operate where others cannot, and that is a significant opportunity for us. And so there are several approaches in the plastic realm of, for processing, and on the left is what we call the thermolysis, the thermal activity, and we put some of the bigger names that you see there in the market, among is BASF, Dow Chemical, that are there, and they are operating today. And the differentiation is, if you will, is that for most of the time, what they do what we call thermal rupturing or bone rupturing, where we are doing chemical deconstruction. So we're doing it with a catalyst and with a chemical agent and a lower temperature. Effectively, we need less capital cost, less operation cost, and our product is better. And so that's one approach. The other approach is just more of a niche market to process a certain type of feedstock that is available through some solvent. And the more common approach is the mechanical. And with the mechanical approach, they are more of a cater to specific solutions. And so again, a niche market, not that it's not a good business. Aduro, we're proud to say that we're standalone in the chemolysis, as I mentioned again, and that gives us a lot of leeway to work in areas that the others maybe need to put a lot of money to produce this thing. And now we're moving just to show you a little bit of what we've been doing in the lab. So the last year, we've been working in the lab, and as we're moving and putting more attention on our commercialization and the pilots, we felt it's time to show you some of the results that we had while we're working towards the pilot. And this is an example of our work on polyethylene. We will produce about 90% a liquid yield that works much higher value than we started with. We end up with a 4% of solid and 6% of gases. From the gases, about 40% are just CO2. So the total emission footprint of this system is about 2.4%. That's how much emission we do. So very, very efficient. And the rest of the gases could be used as to generate the system. That's how we see ourselves in the process. This is how efficient the system could be, and that speaks when we are looking into commercialization, those numbers are making a difference, a huge difference. That translates, and this is a forward-looking statement. This is, again, integration of information that we see in the lab towards the pilot together with our engineering. We've done it with our engineering group that is starting to assess what does it mean in terms of capital cost. And on a single stream type of material, we selected polyethylene to start with, which is by far the most hardest material to operate. We are ready to build pilots in that size, and you can see the numbers now around those pilots. So even a pilot at 10 tons a day, which is not a lot, not a big one, is has a net return after 3 or 4 years already. So very, very small system. So what does it mean? It means that we can do a larger system, but for us to what we will do is we'll just rather than move conceptually to a centralized location, we'll just build smaller systems as we need into a centralized location. I don't think we will ever build a centralized multi-billion-dollar system. We just add trains as we speak. And so for us, a commercial unit is a unit that's worth $20-30 million with a net return of several years. And I'd like you to remember this slide because in some of our slides, the slide that you see in the front, we stated those things, and now in the past 6 months ago, we already saw those things, but we dared to mention it, and now we see it up and coming from the lab into a pilot and through a commercial process. For a little bit to try and give some comparison, the pilots that other organizations are operating for the same size, at least from what we see, worth anywhere between $100 to $200 million. So almost the same output, 50 tons and or 60 tons, whatever there is out there, but we're quarter of that. I'd like to move because I'd like you to ask some questions. I'll run through the next 2 slides because we really want to open the table for the audience for Q&A. Part of our work in the lab was to commit. We had a commitment for our investors that we will show and demonstrate that we can operate in continuous flow mode. So moving from a science experience to a pilot regime, and we're now in the process. We just submitted our work on our report to a third-party evaluation. We're waiting for those results. And with that, we are completing our commitment, to work in the lab, and we have all justification to move away and work on the larger scale operation. And this is again an example of what we're doing with bitumen, and where you can see significant change. This is just a sample, one example of what we're seeing on the results. But what does it mean? It means that we're saving a lot of the blending that is associated with the bitumen on one hand, and we're increasing the value of the material on the other hand. So overall, by comparison, if you would take an upgrading process, which is very complicated, it would the numbers around such operation is about $100,000 per barrel well investment to process. And where we are is about less than $10,000 per barrel investment. So that means we can build smaller operation units that cater to smaller organizations that may not have the opportunities to work on a large capital operation. So this slide just to show where we've been and what we committed to our investors. So running this process at 2021 and speaking to all the pilots in 2022 and start talking, advancing discussions with customers. And this slide is just to show you what we achieved. So we already engaged consultancy and marketing group, and we are in discussion with 3 or 4 from what you see here, already in discussions of pilots. 2 of them are public, the one in the Netherlands and in Ontario. One word about the Netherlands is that it's a very sophisticated chemical hub. They did rigorous research work on what we're doing, and they found us very relevant, mainly because of the same reason I mentioned, that the technology can process plastic that otherwise it's hard to process at the cost. It just costs too much. And so with that, we put our attention on building a new lab in London, preparing some demonstration, increasing our investment in employees, and putting more attention towards engineering. We still stick to the business model of licensing, but there is other opportunities there that we are contemplating, and we'll consider that. And this is a slide that I wanted to share with you, which is, you could see that slide as late as maybe 6-7 months, where we state the size of the unit that we thought 3 to 8 years, and here we are presenting some information from the lab and from our work with engineering doing the same. So all to say that if we've been reserved, we wanted to give the reasons for you guys to stick with us going forward. You see the opportunities that we are working in, in terms of piloting, but you also see that, we've been doing some things for 10 years and now we're moving away. But there is a pace to that, and that's how we will grow out of the lab. I'll leave the ESG and just talk about the share structures, because from environment perspective, there is a lot of benefit and we can speak a lot, but I really want to open the discussions, the room for discussions and the Q&A. And with that, I'm submitting to the audience our share structure. It's quite tight. Clearly, we're undervalued in comparison to what I think the opportunities are there. And if you guys will decide to stick with us in the next 3-4 years, I think we should make a real difference. With that, I'll thank you very much for your time, and perhaps we'll let Abe read some of the Q&A.
Right. So it's Abe Dyke here. We do have several questions here and only a couple of minutes left, so we'll go through them fairly quickly. The first question is, when will the HBU milestone receive third-party validation?
You want to answer that, Abe?
Sure. So considering that we're entering into the Christmas holidays and things are pretty swamped right now, we expect that that's probably going to be sometime in January for that review to be complete. Second question, where would you like to see the company in 2 to 3 years?
Yeah, thank you. We want to see at least 2 or 3 pilots installed and with some commercial deals on the way, basically.
Third question is, are you establishing global partnerships heading into commercialization?
Yes, absolutely. We are, at this point of time, in discussion with, right now, confidentially, 2 major organizations, and each one of them in different sectors. Some of them are in the plastic, the other one is the heavy oil. But we are absolutely looking at this type of deal.
Okay, so fourth question here is, what is the estimated life cycle of a pilot plant?
I assume we're talking about the mission. Life cycle analysis, life cycle.
There isn't any expanded details on that, but I would think that a life cycle, so at the pilot plant, how long will it stay as a pilot plant, and how long would we be doing testing on that pilot plant before we it finishes and moved on to a commercial unit?
So, we're this year probably be ready, at least on polyethylene, at the end of at the end of next year, I'll say, we'll be ready to maybe make designs for commercial unit. And so that will be probably on a polyethylene. And we are in discussion in groups that are talking about small scale and large scale opportunities. And so based on the numbers that you've seen in terms of return on investment, if one of the discussions that we have confidentially, we won't publish who the name is with a representative of an organization that represents 20 municipalities. So, that type of deal is huge. So you put a pilot there, but 2 years later, you don't care about it, right? You just move away. And then the other opportunities are much smaller, I'll say. And so overall, we think that we will sort ourselves with the next 2 years in terms of testing, and about 3 years in terms of approaching working on, let's say on plastics or mixture of plastics. And with that, I'd like to leave the audience with the understanding that because we can do more than what, we're breaking those limitations that a lot of those technologies are there, we don't think we will, fight with the rest of the groups on particular streams. We just think there'll be a large amount of opportunities on the rest of the 90% of mixture of plastics that is out there in different territories, and they would represent different types of deals. They'll represent, some of them will be profit sharing, some of them will be licensing, some of them will be build and operate. So we left that type of philosophy, what type of business model, a little bit open, but we see how fast we can move from the pilot to those business deals.
There are a couple of extra questions, but I think we are at end of time. So with that, okay. I think we'll thank everyone for attending. And if you have any questions for us, certainly do reach out to us by email via our website. Thank you.
Thank you very much, guys.
That concludes today's presentation, and thank you for tuning in.